The last one we're learning about is hydrogen bonds. So hydrogen bonds, as the name suggests, involve hydrogen atom. Now let's first take the example of various molecules and let's see why the hydrogen bond takes place. So let's HCl, HF. So both these molecules, chlorine and fluorine, both of these are more electronegative than hydrogen. So obviously there's going to be a partial negative charge on hydrogen and a partial negative charge on fluorine and chlorine and a partial positive charge on hydrogen. So hydrogen bond is just basically a unique type of a dipole-dipole interaction. So here HF, right? So suppose you have like a lot of molecules of HF in a container. Obviously what happens is the hydrogen atom, which has a partial positive charge, will form a bond with another molecule's partially negative charged fluorine atom. So, and this is called the hydrogen bond. So, hydrogen bond is basically the bond formed between a hydrogen atom which is bound to an electronegative atom and another electronegative and an electronegative atom of another molecule. So here, if you notice, hydrogen is basically acting like a bridge in between the fluorine and this fluorine. This is the covalent bond formed between hydrogen and fluorine, whereas this is a hydrogen bond which is formed between fluorine and hydrogen. And the reason you realize now why we say that it's a version of a dipole-dipole interaction is because if you remember when we took HCl, right, there also we noticed that like there's an interaction between the chlorine and the hydrogen. So hydrogen bond is generally, one more important thing, hydrogen fluoride actually exists as a cluster instead of just HF alone. So one more important thing about hydrogen bonding is it's of two types. It's not included in your syllabus or something, but yeah, there are two types of hydrogen bonding: intermolecular hydrogen bonding and intermolecular. So intra and inter. So intramolecular is within the same molecule, and this happens in like organic molecules which are bulky, and they make sure that the hydrogen and the electronegative atom are in different are quite close together, and that leads to the formation of a hydrogen bond. Intermolecular is between two different molecules, and this is an example of an intermolecular hydrogen bond. The important thing about this thing is that there has to be some amount of electronegativity. So the electronegative atoms not only include nitrogen, oxygen, and fluorine, but they also include chlorine atom as well. And usually the hydrogen bond is denoted by a dotted line. Now the energy of the hydrogen bond, it can be between 10 to 100 kilojoules per mole. So this is the energy of the hydrogen bond. So the hydrogen, this amount is quite significant. So hydrogen bond is actually determinant in figuring out the structure and properties of various molecules. So in organic chemistry as well, the hydrogen bonding, inter and intramolecular, so hydrogen bonding actually determines the things like boiling points and solubility. All of this is determined based on hydrogen bonds only. And you'll be learning about this the next year when you learn about the individual functional groups and the solubilities, the properties, etc., etc. You realize that hydrogen bonding is actually quite important, and that's because the energy of the hydrogen bond is between 10 to 100 kilojoules per mole. Per mole. That's the straightest line I've ever drawn. Anyways, so the strength of a hydrogen bond obviously depends upon the Coulombic interaction between the lone pair of electrons which are on the electronegative atom and the atom of hydrogen. So there is a Coulombic interaction between the lone pair of electrons on the electronegative atom and the hydrogen atom, and that in turn determines the strength of the hydrogen bond. So with that, we're done with hydrogen bonding. Hydrogen bonding is like a type of dipole-dipole interaction, and here you have two types first before that. Here you have a dipole getting created because of the fact that fluorine is more electronegative than hydrogen. So there's a negative charge, partial negative charge, and a partial positive charge. And so obviously the partially positively charged hydrogen atom will attract the partially negatively charged fluorine atom of the other molecule, and this leads to the formation of a hydrogen bond. The energy of the hydrogen bond is quite significant. It's between 10 to 100 kilojoules per mole, and this is in turn, because this is actually pretty high, it determines various structural properties, and basically helps in predicting various properties. The two types of hydrogen bonding, intermolecular and intramolecular. Intermolecular is between two different molecules, and intramolecular is within the same molecule. Now, the hydrogen bonds, the strength of the hydrogen bond is basically dependent upon the Coulombic interaction between the lone pair of electrons on the electronegative atom and that of hydrogen. With that, we're done with hydrogen bonds. Now, the intermolecular forces are not just attractive, but they can be repulsive as well. So this is happening when two molecules are getting very close together, the attractive forces actually decrease, and there will be some amount of repulsive forces between them. And this in turn, so when the distance will increase, the repulsive forces will also increase. And because of this, it is very difficult to compress liquids and solids. So even if you notice, we can compress gases. That's because we have the intermolecular spaces that is between the molecules. But in liquids and solids, if you try to compress them also, it's quite difficult to do so because of the fact that our liquids and solids, as the molecules start to get very close together, they will start having a repulsive force of interaction in between them. With that, we're done with hydrogen bonding. In the next video, we will be discussing about thermal energy. Do check it out.